What is the area formed by triangle A, B, and C when you have 25 of these triangles with unit area? Now I know that a lot of my videos are all calculus based, but this problem just really intrigued me. This is a very simple problem that a lot of people have already solved very quickly just by using some logic and sort of estimating how many triangles this area makes up. But we're gonna go ahead and use linear algebra and some basic areas for equilateral triangles and just regular right triangles. So here's a particular question. We have 25 of these triangles that have unit area. These are all equilateral triangles that are sort of just put together here, and we have A, B, and C that are touching some of the vertices of these triangles, and we want to find the exact area. I think I'm going to go ahead and put the problem here up on the screen so you can sort of guess what problem or what the solution is going to be, and then we're going to get started. Okay, cool. So one of the few things that I'm gonna go ahead and do is one, we're gonna talk about equilateral triangles. So remember, if we have an equilateral triangle, then this has a specific area of √3/4 side squared. Whatever that side is, that's what the area is gonna be. And also, if we just have a regular triangle, then we know, or we should know how to find that area. It's just 1/2 base times height. I want to make sure, or I want to emphasize that we're going to use these formulas to find the exact area. I don't want to do an estimate because a lot of people already know what the answer is going to be, but I want to show you how I would solve it using linear algebra. Now we have the area of the equilateral triangle, we have the area of a regular triangle, but let's go ahead and talk about how to find the area given 3 particular points for the vertices of a triangle. There's a cool formula in linear algebra that tells us that if we were to have the coordinates of A, B, and C, then you can go ahead and find the area by setting this up into a matrix, finding the determinant, and then just multiplying it by 1/2, or dividing by 2 if you want to think of it that way. But the problem is, how in the world do we find these particular coordinates? Because there's no coordinates here, there's no X and Y axis, but we're gonna go ahead and recreate it. Let's just say, for example, this is the origin, and this base right here is gonna become our X axis. I could even draw this in pink. Here we have our X axis. And then I'm just gonna go ahead and draw a straight line here. This is gonna become our Y axis. Now, one of the things that we should know is that the area of each of these triangles have an area of 1. So we're going to utilize this right here because we know they're equilateral triangles and find what each side is equal to. So let's go ahead and figure out that formula. Well, we know the area is going to be 1. So we're going to have 1 equals √3/4s squared, where the side, or s, represents the side length. Well, let's go ahead and just multiply by the reciprocal here, and we have 4/√3 is equal to s squared. That's not bad. Let's go ahead and take the square root, and we're going to get that 2 over the square root of the square root of 3 is equal to the side. Now, this is what sort of intrigued me about this, because you have these like weird numbers or irrational numbers, 2 over the square root of the square root of 3, and I just thought that was really neat. So what's so important about this? Because we know the side is 2 square root 3. So this coordinate right here is 2 over square root 3, comma 0. This is going to be 4 over square root 3. This is 6 over square root 3, and this right here is 8 over square root 3, comma 0. And the reason why I'm using this is because this is 8 over square root 3, and that's what the x coordinate for b is gonna be. So we have 8 over the square root of 3. We just need to find the particular y value, and in this case, it's gonna help us find the a value as well. Let's talk about the a value real quick. Well, the a value is directly below this particular point. So this coordinate right here is actually going to be 4 over square root 3, but we don't know what the y value is, which is what we're going to find out in a second. So it seems like we've done a great job using So it looks like we've done a great job finding the x coordinates for each particular vertex there. All we did was use the equation for the equilateral triangle, knowing that the area is 1. So now let's go ahead and find the y values. So how do we find those? Well, if you have this triangle here, this will represent the height. So we're going to go ahead and utilize this particular equation because we know the area, we know the base is actually 2 over square root 3. So we're going to use that to find our height. Now, how do we do that? Well, let's go ahead and make the area 1 equals to 1/2 times our base, which is 2 over square root 3, and then we have our h value. Well, as you can see, the 2's are going to cancel out, so we have 1 is equal to 1 over square root 3 times h. We can multiply that square root 3 to the other side, giving us square root 3 is equal to our height. Let's go ahead and use this on the x and y coordinate. Well, we have the origin here, so this will be square root 3. We go another height. This is 2 square root 3. Let's go another height. This is 3 square root 3. And then we continue to 4 square root 3. And then we have the last one, 5 square root 3. Now, look at the coordinate for A. That's going to have a y coordinate of 4 square root 3. Now, again, don't be intimidated by these radicals. It's going to cancel out at the end. Well, we have the C value already, which is nice. Our B value has a y coordinate of 2 square root 3, 2 square root 3, and now we can go ahead and utilize this equation right here. Our x1 and y1 will be the coordinate for A, and then we have our x2, y2 for B, and then our x3, y3 for C. So let's go ahead and put that here on this side of the blackboard. Okay, so here we go. We have our x1, y1, x2, y2, x3, and y3. And whenever we're finding a determinant for a 3 by 3 matrix, I just like to utilize the trick where you go ahead and duplicate the first 2 columns on here. So you have 4 over square root 3, 4 square root 3, and we continue that process. We're going to go ahead and duplicate those. So 8 over square root 3, 2 square root 3, and then we have 2 over square root 3, and then we have 0. Now, how do we find a determinant? Well, it's all about just multiplying diagonally. So you're going to go ahead and multiply this times this. So we have this first product right here. Not too bad, right? You notice that when you multiply this fraction times this, the square root 3 cancels out. So we really just have 8 plus, and as we continue, we're going to multiply this times this. So we have this diagonal right there. Well, that is also just going to multiply to 8. And then we continue, and then when you multiply to this diagonal, this times this, well, that's just 0, so we have 0. And now what we're gonna go ahead and do, we're gonna add these up, but then we have one last thing. We need to subtract the product of the other diagonal. So in other words, we're just gonna start off here, and if you multiply those together, you're gonna get a 4. And then we're going to continue, multiply this diagonal here, and that's just going to become 0 because of that 0. So we're going to put plus 0 plus one last one. We're going to multiply this times this, and that's going to be just 32. So you see how nicely the square root 3's cancel out. That really helps us. And I totally forgot that the determinant accounts for a plus or minus. Whether we get a negative value, then we just make sure that we use that negative term over here to make our area positive, because we're looking for an area. All right, so let's go ahead and continue. Everything here is being divided by 2. Don't forget we have a plus or minus. So let's go ahead and add these up. This is 16, so we have plus or minus 16 minus, and then this right here is just 36. So we have 36 right there, all divided by 2. And then we go ahead and subtract this. This is going to be negative 20, and then I'm just going to utilize the negative portion here. So it's going to give me a positive 20 divided by 2, and that's going to be an area of 10. Now, a lot of people already utilize this just by logic. They said, okay, there's a couple triangles here that we can account for, and then they said at the very end that we can just use 10 as our answer. That will be the logical answer there. But I definitely wanted to do a fun exercise using linear algebra. And that's going to do it for today's video. Please, if you like this video or if you wanted to do a different challenge problem, let me know in the comments. Don't forget to subscribe to this YouTube channel and follow me on Instagram or on TikTok, where I'm posting daily content. I'm talking every single day. All right, I'll see you in the next one.